Hi, I'm Curt Frye, and in this movie, I would like to continue my series on the traveling salesman problem. In this movie, we're going to work with a couple of larger problems to show you how Solver works with them, both in terms of setup and speed. If you'd like to follow along, the sample file that I'm using is TSP_larger, and that's an Excel workbook you can download using the link that I provide in the video description below. The first problem I'll look at is on the large worksheet, and here I have a 24-node network. I have the locations for each of the stations over on the left, and then to the right I have the distance matrix, and that calculates the distance between each pair of points. And then toward the bottom, I have a path. The total distance is what is traveled using the stations 1 through 24 in numerical order. And the way that I have the solution set up means that I need to have the first node, which is in cell H27, repeated here in AF27. And currently, the total distance is 635. Below that, I have a different solution, and that has a total distance of 206. So you can see there's quite an improvement. The solver model that I'm using can be found by going to the Data tab, and then in the Analysis group, clicking Solver. If you don't see Solver, then go to the File tab, then click Options, and in the Excel Options dialog box, click Add-ins. Then go down to the bottom, and next to Manage, you should see Excel Add-ins. If you don't, click that, and then click Excel Add-ins and click Go. Then you have Solver Add-in in the Add-ins dialog box. If it's not checked, check this box and click OK. In this case, I don't need to change anything, so I will click Cancel. And now when you go back to the Analysis group on the Data tab, you should see Solver. So I'll click that now. And I have the Solver Parameters dialog box. The objective cell is the total distance traveled. That's F27, which is here. It's a minimum, and we're doing it by changing the variable cells H27 to AE27. And those are the cells that are highlighted here in yellow. And remember that AF27 is a repeat of the first node in the network. And the constraints that I have are that all of the station numbers must be less than or equal to 24. They must be greater than or equal to 1, and they must all be different. And finally, we're using the evolutionary solving method. And what that does is generate random solutions, then take the best ones and use them to recreate more possible solutions and go through a number of generations to find the best option based on timeline settings that we set. The one option that I want to point out, so I'll click Options here and go to Evolutionary, is that we are requiring bounds on variables. That's what the 1 and 24 mean. With that in place, I'll click OK, and then click Solve, and I'll be back when we have a solution. I have sped up time a little bit, so we don't have to wait for the entire model to run. And there we are, total time of 1 minute and 14 seconds. Solver has found a solution that it can't improve upon, so I'll click OK. And we have a total of 199, which is better than the solution that we had of 206 earlier. So it looks like we got a good run, and it didn't take all that long, even for a problem of this size. Now let's take a look at an even larger problem. So I'll go to the larger worksheet. And as the name implies, on this worksheet, I have a much larger problem. And if I scroll down, you can see I have the station list over here on the left. The last station that I have is station number 75. And if I look at the path, we have a list of stations from 1 through 75. I won't scroll to the right. I'll just ask you to believe me. But the overall setup is exactly the same as what we had on the large worksheet. So now I will go back up to the top And we can take a look at the solver model, which is based on this worksheet. So I'll click solver. And here you can see it's very similar, just the cell addresses have been changed. The objective cell is D80, and that's here. We have a minimum value, and then by changing the variable cells from E78 through CA78. So there's E78, and it continues on all the way to the right. The numbers are subject to the constraints where they must be greater than or equal to 1, less than or equal to 75, and all different. And everything else is set up the same. I have required boundaries to be set on my variables. So let's go ahead and run the evolutionary solving engine and see how long it takes to get our solution. And remember, our current total is 4143, and that's just doing the stations in order, so I bet we can do a lot better. I'll click solve. For this one, let's start the timer, and I have sped up time even more. And you can see why as we go past 2 minutes. And end up with a total running time of 5 minutes and 7 seconds. We have our solver results, and I'll click OK. And we have a total of 789 for a 75-node network, and that is very impressive. So let's see why it took so long to run, and also why it stopped so soon after we reached what is probably close to the optimal solution. So I hope you enjoyed this movie and seeing that the evolutionary engine can even handle extremely large problems. You have a limit of 200 variable cells. That is, we could look at networks of up to 200 nodes, but in this case, you would probably be fine using the evolutionary network for local deliveries or other items for small businesses. Thanks again. I'm Curt Frye, and if you enjoyed this video, please like it and subscribe to my channel.